Okay, so now let's continue to find V. So in order to find V, we can see that there's a change in the velocity from this position to this position. And then it will under the work done by all the total forces acting on this one, right? So it means that we need to do a little bit of the free body diagrams here, which means that we need to identify all the forces that acting on the system. So it's travel horizontally. There should always be weight, right, on the system. And then because it's travel on a surface, whenever we have a surface, there should be a normal force. And normal force, then it should be normal to the surface, right? The surface is the horizontal one. So both the weight and the surface is perpendicular to this one. And actually that's also like the directions of the motion. Then we also have mu as well, which means that mu is the coefficient of the kinetic friction, which means there should be some friction in the opposite directions to the motion. So now we have all the forces. Then we need to identify the work done by the total every forces here. So let's just have a quick remind about a quick remind of the work. Work is defined as force, just the magnitude of the force. We just care the strength of the force, how strong it is, times with what? Yeah, the cosine theta times with displacement. And we just care about the magnitude, how far it's travel. So just the magnitude as well of the displacement. So both force and displacements are vector. That's why it makes it so special that we got theta is the angle between the displacement and the force vector. So depends on the angle, then we can have different kind values of the work. So we can see here, if we list them down here, then the work total here should be the work done by the weight. I don't want to write like WW because it can be confusing. So I would just like try as like W of the mg because it will represent for the weight. And then W by the normal force, and the W the work done by the friction, right? And then I will apply these equations for each of them. Okay, so for the weight, that should be the weight itself, and then there should be the angle. This is the displacement, right? Let's draw the vector displacement here. This is the S displacement, and actually it also the horizontal in the same direction with the vector V. So to see the angle here from S to the work, how great is it? It's 90, right? Yeah, it's very special. It's perpendicular, vertical, and horizontal. So then there should be the weight is mg's time with cosine of 90 degrees time with displacement s. Yeah, but there's something special about this one because cosine of 90 actually just 0. So then the whole thing just go to 0. It means that the weight does not do any work on the system when it travels horizontal because it doesn't help, right? It doesn't help or even against when it travels horizontal. It's just perpendicular. So can you guess what is the work done by the normal force? Can we do it really quickly, right? So the normal force here is that this one, the displacement is this way, S, this is N. What is the angle here? Another 90, right? So the work done by the normal force as well also be 0, right? Yeah, it's also 0. So we good with that? And now what about friction? Friction is the opposite direction. This is the displacement direction. So what is the angle from the displacement to this one? Oh, right? Yeah, it's 180 degrees. And actually cosine of 180 degrees is a minus 1. So can we make it shortly here? Because I kind of like, I want to do in the trap, so that I don't want to add on the details here. Can I make a minus here? That is from the -1 here, and that should be the magnitude of the frictions time with the displacement s. Is it good? Right? So that basically, when we have them on together, this one just simply left minus f time with s, right? This is everything on the right side, right? That's the work total. So what about the left side? Do you want to do it yourself here first? And then let's check it together on the next video. Yeah, I want to like just pause like step by step, then after I give you a chance to like do it by yourself as well, and then we can just work together on the next one. Okay, see you soon.